Hello everybody, before the online tutorial lesson on Wednesday, I would like to use this clip to summarize Chapter 8, the Logarithms. So today I would like to bring to you also the Chapter 8.4 and 8.5, although those 8.4 and 8.5 are optional. It means that you will not see them in DSC paper, but it is some kind a little bit interesting for you to learn more about logarithms. Okay, so for the chapter 8.4 and 8.5, actually the book tells you about some applications of logarithms in using in science. For example, you can see that the first one is called the Richter scale. Actually, the Richter scale is the measurement after the earthquake. 地震 in Chinese. Okay, that means that actually the logarithm will be also one of the measures for scientists to measure how strong is an earthquake. Besides of earthquake, you can also see sometimes something is called the intensity factor for sound. So usually you may hear something is called decibel dB. Okay, but don't worry because this session is totally optional. That means that even you do not learn everything about this session, you will have nothing about the DSC because DSC will not ask you to memorize those formula in chapter 8.4. So for example, this kind of formula, for example the Richter scale, actually you don't need to learn. I don't say that it is not useful, but actually it's not, you will not be asked in DSC, and also the intensity of sound will not be asked in maths. So you may just ignore them if you have not time to read your book. And also you can see that after the chapter 8.4, you will also have something, the history about the log tables and slide rules. As I mentioned before, the logarithm actually used it many years ago in most of the Europe countries because at that time the navigations 航海 traveling over the sea. Okay, the scientists or the people have to calculate many numbers. For example, some big numbers multiplication for their navigations. So they have to use a useful tool to help them calculate the numbers faster, so they can use a lot. So if you want to learn more, okay, you may ask me after we go back to the school to read some history about the log. For example, sometimes it's a log table. I don't think that you will see this table, okay, in your textbook or in other books. But when I was a secondary school student, my textbook really had this table. So later I will tell you if you are interested, but don't worry again, those things are optional again. That means that you actually don't need to read this session. That means that actually you can see for the chapter 8, what you need to learn and to read would be just only chapter 8.1, 8.2, and 8.3. So I think that I have to skip this one. For example, the log table, the reverse log table, or we say the anti-log table, and the last one is slide rule. So I would like to say that this is a very special ruler because this ruler has the log scale. I know that in one for them, some teachers always say, I can show one of the teachers have this slide rule. Even I don't have the slide rule actually. But anyway, so this is a very interesting thing if you want to learn. But anyway, so I'll just give a summary. Please remember, the summary has been printed in your book, page 43 to 44. So I think that you can read by yourself. But before I end this clip, I would like to bring you two important notes about logarithm, which are also included in chapter 8.1 to 8.3, and the number 2 will not be included in examples that you can see in chapter 8.1 to 8.3, but you will be asked in DSC. But now I'll just give you the first note. So the first note is the chapter 8.3, the book page 28, example 12b, this example. So if you still remember last clip, I also gave you the example like this one. So I can turn back to let you see which example. So actually it is this one. So can I see the questions here? Yeah. So you should be there. So please wait for a moment. Yeah, this one. Now, so this one would be your book, page 28. The question, the example 12 question B. Okay, so this one. So if you still remember last lesson when we talked about the chapter 3, you can see the book showed you the method using taking log on both sides, and the log are base 10 common log. So after you have taken the log and using the rules of log to simplify, you can group those with x together, those without x just only number or log on the right hand side, and then you can take it out the x and then you divide the numbers to the right hand side, then you get the answer. So this is the way that we can take log to simplify those problems with the power with x or variable as the power. So this is the way that we can use. But I would also like to say is that when you are doing the classwork involving this kind of question, I would like to bring to another way to do this question also, is that I can also do with using log index. And lastly, we just only use log in the last step. That means that throughout the whole process, I do not use log, but I only use log in our last step. So what is going about? So actually now I am using the log index. That means that now, for example, the first one, 7, and then multiply with 2 to the power 1 minus 3x. So you can see this step, I can actually use the log index only to separate as the multiplication of terms. So here I would like to remind you that what I'm doing is that because I can see 7 and 2 to the power something are multiplying to each other, so applying the log index, I can make them still multiply one by one by separate writing them. For example, 7 first. And then for 2 times 1 power 1 minus 3x, I can also separate the index as 2 products as 2 to the power 1 and 2 to the power negative 3x. Do remember, because 7 and 2 are multiplying together and 2 is also multiplying together after separation, so don't distribute inside. That means that the 7 will only multiply once on the left, and then with 2 to the power 1 and 2 to the power negative 3x. And then for 3 to the power 2x, you just put it here. Then now, what we can do is that we can combine those with only constants. For example, 7 and 2 to the power 1 to becomes another number. For example, you can see it now, I've combined it and it becomes 14. And then for 2 to the power negative 3x. So please remember is that you can first to make 2 to the power negative 3 and then to the power x out. Then you can see 2 to the power negative 3 is just only 1 over 8 because it just equals to 1 over 2 to the power 3, which is 1 over 8. That means I can make it like this. So you can see that after you have made it the things like this, so you can see now the equation, all the sizes will only have 3 terms. 14, 1 over x to the power x, and 9 to the power x. Then this time, instead of grouping the x by taking out the x, but now we have to group those with power x together. So it's very similar to taking log, because for taking log, you group all the terms with x together and then you take out the x as the common factor. This time, because you haven't done log yet, so the power x is still in the power. You will not have the multiple. But we can also group those terms with the power x together. Just like here, I can make the 1 over x to the power x multiplied to the right. That becomes x to the power x, because this one is just like you are doing the multiplication and then to make this one. Then 9 to the power x is still on the right. Then do remember is that as we have learned a rule is that if the 2 terms we have the same power, for example 9 to the power x also have the power x, then we can combine them together by multiplying the 9 and 8. So you can see that here I use a step is what? I use a step to combine 9 and 8 to become 72x. So the equation will become this one, 72 to the power x equals to 14. So it becomes very easy because you don't need to do so many terms, just like you can see in the book, many terms here, but here I just only simplify the problem with only 2 terms, one on the left with power x, one just only the number on the right. Then because this term are very easy, so you can use the definition directly to make it as log base 72 and then 14. Because this one, 72 to the power x equals to 14, is the basic representation about the log. If I apply the definition of log here, so you can see that the answer can becomes very simple. That after you press using the calculator, you can see the answer should be the same as what you see in the Chapter 8.3, this example. So you can compare. This one you may have to write so long, many long steps. For this method, you can write the things in a more simple way. And also you can see the answer can be very simple, like only log 72 equals to 14. But you may ask, oh Mr. Wong, what is the difference between this and this? Actually, I would like to say they're the same. The only difference is that you are applying the law of index, or you are applying the properties of log. If you take log first, you do all the things with log property. If you take log the last, you have to do the index, so you use a log index. And you can also compare that now. If you see this method, you can see that this one, you have the fraction. The numerator would be log 7 plus log 2, but this one is also equal to log 14 because log 7 plus log 2 is just only equal to log 14. And also besides of log 14, this one, you can also apply the log index again, but before you have to put the power back to 2 and also the power back to 3. So you can see this one will be log 72. Then you can see the whole thing is actually becomes log 14 over log 72. But you know that log 14 over log 72, you choose to change the base formula, you will also have exactly the same as log 72 as base, and then you take the log on the 14, which is the same as the answer you can see when I use the log index to do first. So I would like to say that actually the both methods are giving you the same answer because they are actually equivalent. I know statistics they should be equivalent. That means that no matter which one, you can go to the other step or the vice versa. So try to see whether, okay, if you are doing a classwork, you feel very difficult when you take log, so you may try using this method. It may let you do in an easier way. Okay. So besides of this note, the second note I would like to talk to you would be the kind of question you will always see in DSE, but it is not shown in any example from the book, which is this one. So you may turn the book to page 52, the supplementary exercise, question 47. So you can see that for the question 47, this question we give you the graph, and the graph is talking about the xy coordinate plane, but this time is not purely x and y, because you can see this time I give you the y axis is still y, but the x axis, or we say horizontal axis, this time is log x, but I will give you the log small 2x. So the difference between this and xy is just that you replace the axis with another variable. But do remember is that because you have changed another variable, you may be connected with the equation of the line. Now you can see the book said this one is the equation of the graph. That means that now this straight line, okay, representing x equals to p times q to the power y. But actually this one is not exactly representing the general case that we are thinking about, because in this coordinate plane we are talking about log 2x and y, but this relation is talking about x and y. So there is a difference is that now the variable are different. So because they are different, we cannot just apply x equals to p q to the power y directly to the graph. That means that we have to do some changing to make it becomes the way that we can see. So we will call this kind of question is to convert the function into linear functions. And the way to convert it is to take log. But why do we have to take log? Because first of all, you can see that in the graph, the axis is showing you the log 2. And also the second way is that in order to make it like a straight line, you cannot power. Because if you still remember equation of straight line, we will never have the power, okay, onto the variable. The variable itself is a power. No. So we have to take log to take the power out from the index. So this time I take the log 2. Why? Because you can see the graph is using log 2, so I can take the log 2 here. So after you take the log 2, you can see at the right side p times q to the power y will become log 2p plus log 2q to the power y. Just use the first rule. And then for the last term, this one, you apply the third rule to take out the y. So it becomes a relation like this. But now we will have to try to do a very important step, is that we have to rearrange the term to make it become this way. Y equals to 1 over log 2q times log 2x minus log 2p over log 2q. So why do we do this? Because you can see now if I write it in this way, it is just like what you have seen before as y equals to mx plus c. So if you still remember, this one is the form of equation straight line. Because, and also you can see the graph is showing the straight line. That means that we have to change the things in terms of log and also in terms of straight line. And why do we have to start y first? Because y is the variable into your vertical axis. Just like for the equation straight line, we write the y first, the vertical first. So we write the y. So why do we have to divide the subject? Is because now we have to fit as a line. Originally, you can see that it has x as subject, but this time we have to write in y because we have to fit the straight line. And also you can see that here, y and log 2x are the two variables on the axis. That means that all the other things should be unknown constants. That means that they are not changing number, but they are the number which are known. So you have to find them. And how do we find them? So you can see that in front of log 2x, it is 1 over log 2q. If you still remember y equals to mx plus c, the letter in front of x should be slope. So here also, the things in front of log 2x should be slope. So we will say in this question, I can say log 2q, 1 over log 2q is our slope. And then the other things in other than x, for example, here you have minus log 2p over log 2q, should be the y-intercept. That means that the intercept in the vertical axis. That means that after you have got this relation, now how do we find the p and q? We will say that now we have to take out these two terms, the things with slope and intercept in the vertical axis, to write. So I would like to show you here. So we will say that the slope, as we said, we will have 1 over log 2q. And also in the given picture, you will see that the 2 points are given, which are 3, 0, and also this one is net 0, negative 3. So we can apply these 2 points to find the slope by simply using y2 minus y1 and then x2 over x1. So you can see at this time, you will have 1 over log 2q is equal to 1 because the slope is 1. So you will also have log 2q is 1, so you have q should be 2. Because 2 to the power 1, 2 to the power 1 is 2, so it should be 2 here. So this is the way that we find one of the variables. For example, you find q for using the slope. After we have used the slope, then you should remember that also we have to use the intercept. That means that this time I want to use the intercept, and this intercept is on the vertical axis. I don't write y because it is not always y, but here it is y, so it's just a coincidence. But actually, I can say the intercept on the vertical axis. As we said, including the negative side, log 2p over log 2q. This time, this one should be equals to the intercept vertically. And you can see the intercept vertically would be the number here, which is this number, negative 3. That means that what you need to do is that the next is you have to put the negative 3 here to let you calculate. So here you have negative 3. Because you just found log 2q is 1, so this one will become negative log 2p, and then equals to negative 3. So you cancel the negative side, then you can simply to get p is 2 to the power of 3, which you get 8. So actually we find the values of p and q using these two information, which are the slope and the intercept in the vertical axis. And before you use them, you have to arrange your equation in the form this one. Y equals to something with log 2x plus or minus something. Now, so this is also one of the problems that you need to practice. Usually you will see them in MC questions in DSC or also in exam. Try to do it by doing the following classwork. So these 4 number of classwork, the first 3 are very simple application problems. And this application problem, don't worry, because we have already given you all the formulas. What you need to do is just you apply the formulas and then you solve the problem. The last one, question 48, is a challenging question. This question involves the example like the question 47. Try to do that today or tomorrow. And make sure that you hand in all classwork, I mean chapter 8 all classwork, on or before tomorrow. Because this Wednesday, the 26th of February, I will upload the detailed solution. That means that my written solution to your Google Classroom, and you may download first, and then in the afternoon, our online tutorial lesson, I will also explain what I've written in the written solution to you, so you can print out or you can just use your tablet or mobile to see the PDF. And when you are joining the hand-on listening tutorial lesson, so you can look at your mobile and see my solution and then listen to me. It may be more easier to understand. But make sure you have tried to do some questions. I know now you have so many homeworks because every subject would give you homework. But try to do some of the questions even you don't have enough time. Okay, so I don't know whether other class math teacher will allow you to do later or not, but for my 4C, I think that you can try to do as many as possible. At least each homework you do 1 or 2 questions. That means that I don't suggest you skipping one homework, but you can just finish some of part of the questions in the homework. But make sure you have some insights before you listen to me. Otherwise, you will not understand what I will tell you. I will talk to you. Okay? So anyway, please keep your problem. Please keep your questions on Wednesday. Ask me or ask us in Wednesday online tutorial lesson. Boys and girls, see you all. Have a happy day. Goodbye.